Welcome to SWECODES. In today's mock interview simulation, we'll tackle a common interview coding problem, finding the longest substring without repeating characters. This challenge is a great way to sharpen your problem-solving skills and master the sliding window technique. Watch as we break down the problem step by step, explore the technique, and demonstrate how to implement the solution efficiently. Let's dive in and code together. Let's begin the mock interview.
Let's discuss the problem about finding the longest substring without repeating characters. Given a string, you need to find the length of the longest substring that contains no repeating characters. For example, if the input string is ABCABCBB, the longest substring without repeating characters is ABC, which has a length of 3. Does that make sense? How would you approach this problem?
Yes, it does. Can I confirm that the substring must be contiguous? Are there any constraints on the length of the input string? My initial thought is to use a sliding window technique. Here's how I would approach it step by step. I would use 2 pointers to represent the current window of characters. I would maintain a set to track unique characters within the window. As I iterate through the string with the right pointer, I would expand the window and check for duplicates. If a duplicate is found, I would shrink the window from the left until there are no duplicates. Throughout this process, I would keep track of the maximum length of unique substrings. Let's walk through an example. For the string ABCABCBB, start with both pointers at the beginning. Expand the window to include R, B, and C. When encountering the second A, shrink the window from the left until I is unique again. Continue this process and update the maximum length as needed.
1. Start. The process begins. We are tasked with finding the length of the longest substring without repeating characters in a given string. To initialize, we initialize 3 variables. Charset is an empty set that will be used to keep track of unique characters within the current window of the substring. Left is a pointer initialized to 0. It represents the starting index of the current window. Max_length is initialized to 0. This variable will store the maximum length of a substring without repeating characters found during the process. 3. For each character in the string, we start iterating through each character of the string using a right pointer, which represents the ending index of the current window. 4. Is the character in charset. At each step of the iteration, we check if the character at the right pointer is already present in the charset. 5. If no, character is not in charset. Add character to charset. If the character is not in the charset, we add it to the set. Update max length. We update max length to be the maximum of its current value and the size of the current window, which is calculated as right, left plus 1. 6. If yes, character is in charset. Remove character at left from set. If the character is already in the _score set, it indicates a duplicate. We need to adjust the window by removing characters starting from the left pointer from the set until the duplicate character is removed. Increment left. We increment the left pointer by 1 to shrink the window from the left side. This continues until there are no duplicates in the window. 7. End iteration. Once the character at the right pointer has been processed, either added to the set or the window adjusted to remove duplicates, the iteration ends and the loop moves to the next character in the string. 8. Output max_length. After iterating through the entire string, we output the value of max_length. This value represents the length of the longest substring without repeating characters found in the string. Now, let us go through the explanation highlighting the main steps and logic used in the code implementation. We start by importing necessary classes, hashset and set, from the Java Collections framework. We then declare the class longest substring without repeating characters and define a method length of longest substring that takes a string s as input and returns an integer representing the length of the longest substring without repeating characters. Inside this method, we initialize a hashset named charset to store unique characters, an integer left as the starting pointer of the sliding window, and an integer maxLength to keep track of the maximum length of substrings found. We iterate through the string using a right pointer. For each character at the right pointer, we check if it is already in charset. If it is, we enter a while loop to remove characters from charset starting from the left pointer until the duplicate character is removed, incrementing the left pointer each time. After ensuring the current character is unique in the window, we add it to charset and update maxLength to be the maximum of its current value and the size of the current window. After iterating through the entire string, we return maxLength as the result. In the main method, we test the length of longest substring method with the input string pwwkew, print the result, and close the method and class.
Perfect. You've explained your approach very clearly. One last thing before we wrap up. Can you mention the time complexity of your solution?
Sure. The time complexity is big O of n, where n is the length of the string. Each character is processed at most twice, once by the right pointer and once by the left pointer.
The algorithm used to solve the problem of finding the length of the longest substring without repeating characters is the sliding window technique. This technique is particularly useful for problems involving contiguous subarrays or substrings. What do you think about this mock coding interview simulation? So why not give it a try? Dive into the code, experiment with different inputs, and watch as your solution handles each case with elegance and efficiency. Grab your keyboard, fire up your IDE, and start coding. Happy coding!